covering the lab. So if you want to complete that with us as we go along today, then you're welcome to print that out, or you can just take some notes and then transfer it over. So this is very exciting, and it's not too difficult. So we're going to walk through the steps today. I know I've had a lot of students email me with questions because it is pulling. There's 5 questions about building the electromagnet, and then there's 3 questions on building a motor. And so a lot of students haven't really read through the directions, I guess, and they were kind of a little confused on getting the answers to the first 5. So we're going to take a look at all of those things together and make sure that you guys are in a good spot to get this done and turned in. All right, so just a reminder, you guys are able to use the chat features as we go along, and remember not to share any personal information. And our objective today is we're going to interact with each other. We'll complete this lab together and celebrate that it's the very last one, and we definitely want to have fun together. So part 1 is building the electromagnet, and that is done in a lab or 2 before you get to the motoring on lab. So if you guys are not able to do this experiment on your own at home, maybe you don't have some of the materials, or maybe you're really short on time, then we can complete this together by watching this video. So this lab is not set up exactly the same, but it will allow you to answer the questions in the lab. So I'm going to pull up that video clip, and we'll take a look. Just kind of get the basic information and then understand the parts of the electromagnet and how everything works so that we can answer those questions. So here comes the video for the first part of the experiment.
This video will show you how to build an.
All right, so were you guys able to see that video pretty clearly? Make sense? Everything was good? Okay, perfect. All right, so let's make sure that we understand what you have to build an electromagnet. So remember, this was done in the lab, a couple labs before motoring on. And if you look through that lesson, it showed you some vital parts that you have to have. So a power source or voltage source. I know the wording of it confused people. They didn't understand it was really just a battery. You've got to have the wire. And then this little piece here is representative of what would be like those alligator clips. It's just turning it off and on. It's connecting it. So you may not have that. You may have alligator clips. You may just be wrapping the wires around it. It's got to connect those to the battery. And you're using maybe a nail. If you saw in the video, he had a bolt, which was much thicker. That could affect your strength of the magnet. The number of times the wire is wrapped around is also a factor. So if we take a look at that lesson, just pulling the most important information out, to build an electromagnet, you wrap a coiled wire around a nail or a screw, so something that is metal in the middle. And so the question it asks is, what was the role of the metallic core? And the answer to that is the metallic core has those magnetic domains that line up, and when they are exposed to that electric current, those domains line up and it becomes a magnet. So remember, not every metal is magnetic. So if you try to stick a magnet like on an aluminum soda can, you'll know that that doesn't work, but it is metal. So it has to be a certain type of metal. And the next one, is the metallic core necessary to make the magnetic field? And the answer is yes. The magnetic field is produced by the wire carrying the current, whether or not there is a magnetic core. Okay, so the field is produced by the wire. The metallic core is what makes the electromagnet stronger. Okay, but a lone coil of wire with the current running through it would still act as a magnet. So that's interesting. You could have a coil of wire and that be a very weak magnet, it's produced, so we understand that the magnetic field is produced by the wire and the current. So the core is what is making it stronger. So that's an interesting component to think about there. All right, so as we go on, I have my blank slide in there, sorry. So it talked about two things that you could do to make your magnet, your electromagnet, stronger. And do you guys remember what those things are? This is something that does come up again on the test and in quizzes, so I wanted to make sure we have this information. Do you remember the two things that you can do to make your magnet stronger? We just talked about one of them. There's actually a couple things that we can list. Yes, Divya, great. You can wrap more wire around the nail. That's one thing. You could have a thicker nail. So if we look in that lesson, it just said adding the metal piece in the middle, the metallic core, makes that magnet stronger. So if you had a bigger nail or something, it would increase the magnetic ability. And then you can also increase the voltage of the battery. You can have a stronger battery. All right, so when you guys open up the motoring on assignment, you see the electromagnet questions, 1 through 5. And so I know a lot of students open that and they were like, wait a minute, this is a motor lab, and they see these, but these two lessons tie together. So we want to make sure that we're able to answer all of those. So let's go ahead and take a look at the first 5 here. I'm going to try to change the ink color so that it's a little easier to see for everyone. Okay, I think that should do it. All right, so how many paper clips did the wire wrapped around the nail just a few times pick up? So even though we didn't see that ourselves or test it ourselves, we know that it wouldn't pick up as many as if we wrapped it more times. So you could answer anything here like 3 to 5 paper clips, and that would be fine. Okay, so just an understanding here that the more times the wire is wrapped around the nail, the more paper clips, the stronger your magnet is, the more paper clips it would pick up. So which electromagnet design would be the most successful? So what do you guys think here? I see Divya already typed more wire around the nail. So that is correct for number 2. Yep, so the design with more, hi Ian, with more wire wrapped around the nail. All right, so that's number 2. That would be a stronger magnet. And number 3 says, would wrapping the wire more times around the nail make it stronger or weaker? So these questions are pretty redundant. It makes it pretty simple. What do you guys think? It would make it stronger. Yes, so we've proven that. And then what do you think the result would be if the iron nail was much thicker? So what would happen? What would go on with our magnet? Yes, we would have a stronger magnet, right? All right. You're exactly right. It does increase the surface area too, so you could have more room to pick up more paper clips. All right, so we have a stronger magnet. All right, and then finally, number 5 says, what do you think would happen if a wooden stick was chosen as the core instead of the iron nail? And this is interesting because of what we read a little bit earlier. We know that the wire alone does create a weak magnet. So maybe it would pick up one one paper clip. I mean, we don't know, maybe two, just based on the fact that the wire is creating a magnetic field. But we do know that wood, right, exactly, is not a good conductor for the current. So the wood is not going to at all increase our magnet strength. So in here, if you write nothing would happen, you know, the wood is not magnetic, that's mostly correct. But we also want to take into consideration that the wire alone creates a magnetic field, although not strong. It may pick up one or two. Well, let me go to the next line. Paper clips. The wood core would not increase the magnet strength. Okay, so we kind of went, you know, a little above in this answer. The lesson does show us about the wire having the magnetic field, so we're including that in there. But we also do know that wood is not a conductor, so not really much is going to happen there. All right, so this answers 1 through 5 for you on that assignment page. You're done with the electromagnet portion, and now you're ready to move on to the motor investigation portion. And building a motor is a pretty, you know, technical. That little lab and assignment is got a lot going on. So if you're short on time and you don't have the ability to do it, I encourage you to watch the video. This is an older video. It's from a TV show that used to be on when I was a kid, so a very long time ago. It was called Mr. Wizard, and he was kind of the first Bill Nye, if you will. So he has a little show, and he's showing this boy how to build a motor, and it's kind of a long video, so we're not going to watch the whole thing. I am going to put the link in chat for you, so if you wanted to go watch the whole thing later, just to get a better understanding of how the motor works, you could. So there's the link, and we'll go ahead and watch a little bit of it just to get us an idea. So here comes that video. All right, guys, so we'll stop there. You get a good idea of what's going on. You're seeing the wires and the magnet and how they're working together in order to create and make the motor turn. So with that, we're able to now kind of take a look at the parts of the motor. So this is from the lesson. Obviously a much simpler setup going on here. And so this picture is showing how the motor transforms the electric energy stored in the battery into mechanical energy of the moving wire coil. So remember, when you see mechanical energy, something is moving. And in a motor, something is always moving. So if you're trying to identify if something is a motor, you've got to see if it's got moving parts. So it's basically just an understanding of how this works, and this is question number 2, I believe, on the lab. It's asking how does the electric current change over and turn into mechanical energy. So you've got the electric current, and it is magnetizing the coil. So you can see the coil here, right? My pointer, sorry, is not on. And then that turns that coil's magnetic field, and it's repelled and attracted. So remember, kind of the north-south, north-south, as it rotates. That's what makes it rotate. Okay, so you've got to envision some wires being connected here. That's giving the electrical energy form and causing then the magnets are causing the rotation. All right, so just a good understanding of how it works. So for question 1, it's asking to describe the components that are necessary to make the motor run, and what do they provide. So if we wanted to type those things in here, we know that we have to have a battery that's given in the example. Provides the voltage source, which is the electric energy. Okay, what else did we have? Any other parts that you can remember we just looked at? Okay, we have a magnet. We remember that. Okay, so let me see, the chat's scrolling just a little bit. I can see y'all are typing. So the magnet sets us up for the north and south poles, provide the polarity to make the coil spin. Okay. And then we have the wire coil. All right, let me see. The wire coil. What do we want to include here? Yes, mechanical energy is used, is what is the output is, basically. So it's causing the turning motion. Yes. So the wire coil is conducting electricity. Basically, it's carrying the current, right? Carrying the current. Okay. And then we had anything else? I think we're pretty good there. We have the wire, the coil, the magnet, and then we have the wires, right? There's a coil, and then there are wires that are connecting. So I don't have room to go under it, but I'll put wires connecting the battery to the coil. Okay. So I think we're good. All right, so if we move on to number 2, how do we describe what's going on with the mechanical energy? Transforming, so making mechanical energy from electrical energy. We have electrical energy starting in the battery. It is carried through the wires to the coil. And then what do we have happening? The magnet turns the coil. Right. So it's causing the coil to move, and that creates the mechanical energy. All right, think we got it? Yes. All right, so I think Divya put that in there as well. Good. All right, and then finally, the last question just asked 3 appliances in your house that use a motor. And those are pretty easy to think of. Lots of things, right? If you think of anything that you connect to electricity, then you've got motor, right? A motor running. So I can name a lot of things just in the kitchen alone, but Josh said a fan and a drill. That is correct. Whoops, it's not letting me type. Fan, drill, a blender, perfect. Your mixer, hand mixer, perfect. So all of those things. A lawnmower for sure. Yes, you have a motor there. So all of those things would count. All right, so we have answered all the questions, which is great. And then you're ready to go ahead and upload your assignment. So you guys remember how to do that. You've been successful all year. So with that, We don't have time for our Kahoot game today, but you have finished the lab and you're all done with the course. So congrats. Thank you so much for your help. And if you have any questions about anything coming up with the course, you can hang out and ask.